This lesson is on simplifying radicals.
Our first problem says to simplify the square root of 12. Before we get started on it, I just would like to point out that the way I wrote square root of 12 is different from the way you would usually write it. You would usually write it with a bar over the 12 on the square root sign. I wrote it how it looks on your calculator. Okay, so that's why this bar does not extend here. It's just on your calculator. It looks a little different, but it's the same problem. Now, the way that we go about solving these is by first breaking 12 into its prime factorization. So, for example, 12 is another way of saying 4 times 3. And 3 is a prime number, but 4 can be broken down into 2 times 2. So 2 times 2 is 4, and then times 3 is 12. This is 12 broken into its prime factorization. Now when I simplify the square root, I look for groups of 2 in the prime factorization. So there are 2 2's here. If there are 2 of them, that means I can bring them outside the square root. So 2 2's inside the square root becomes 1 2 outside the square root, and there's still a 3 inside. So my final answer is 2 times the square root of 3. That's the square root of 12 simplified. And if you want to double check it, you can type in the square root of 12 onto your calculator, and then type in 2 times the square root of 3 in your calculator, and you should get the same decimal. Our second problem has us simplifying the square root of 20. The square root of 20 can be simplified by first breaking 20 into its prime factorization. 20 is another way of saying 2 times 10. 2 is a prime number, but 10 can be broken down further. So our 2 stays, and 10 can be broken down into 2 times 5. 5 is also a prime number, so the factorization of 20 is 2 times 2 times 5. Now we can simplify the radical. Since there are 2 2's, we can bring them both out, and we get 2 times the square root of 5. And that is the root of 20 simplified. Our third problem looks pretty hard, but in actuality, if you go slowly, it's not. 1800 is a big number, but if you look at it, it's even, so we can break it into its prime factorization somewhat easily. The root of 1800 is the same thing as saying the root of 2 times 900. Because we noticed that 1800 was even, so we can divide it by 2, and we get 900. So 2 times 900 is the same as 1800. 900 is also even. If we divide 900 by 2, we get 450. So this 900 is the same thing as saying 2 times 450, and this 2 that was multiplied by the 900 comes down again. Now this 450 is even. We can divide 450 by 2, and we get 225. So our first 2 2's stay in the radical, and 450 is 2 times 225. Now for the first time we have an odd number. But if you look, it ends in a 5, which means 225 is divisible by 5. Since this is starting to get messy, I'm going to write down these first 3 2's right here. 2 times 2 times 2. And 225 divided by 5 is 45, which means that 5 times 45 is 225. So 225 is another way of saying 5 times 45. 45 can be broken down again. You can divide that by 5. So we have 2 times 2 times 2 times 5, and 45 is the same thing as saying 5 times 9. Now we're almost there. Since 9 can be broken down into 3 times 3, we can leave all our other prime numbers, 2 times 2 times 2 times 5 times 5, and 9 is 3 times 3. That is the prime factorization of 1800. Now all we have to do is look for groups of 2. There are 2 2's with 1 left over. There are 2 5's, and there are 2 3's. So on the outside of our radical, we write 2 times 5 times 3. And on the inside of our radical, we only have a 2 left. And we can simplify this because we know what 2 times 5 times 3 is. It's 30. So our final answer is 30 times the square root of 2. Our last problem is somewhat of a trick. It's the square root of 87. 87 can be broken up into 3 times 29. The trick here is that 3 is a prime number and 29 also is a prime number, which means neither one can be broken down any further. So there are no groups of 2. I can't circle 2 3's because there aren't 2 3's and there aren't more than 1 29's. So the square root of 87 simplified is exactly that. It's the square root of 87. That would be the final answer. So if you recognize this right away, you don't have to do any more work. But if you don't, you do have to break it down into its prime factorization and show why it cannot be broken down anymore.
And that is the end on the lesson on simplifying radicals.